So in this moving charges and magnetism topic, so you must and should remember that. So in previous topic, electric charges and fields and electrostatic potential and capacitance, so those topics are under the electrostatics. Why? Because in those topics, so we consider only the electrons are at rest position, the charge is at rest position, static, stationary position. So but in this topic, so we have to consider the charge is in motion. So that's why whenever if the charge is at rest position, then electric field is generated at everywhere in its surroundings by the charge. But here the charge is at rest position. If the charge is at rest position, so either it is positive charge or negative charge, the charge at everywhere so produces the electric field in its surroundings. But if the charge is in constant velocity, that means the charge is in motion. So the charge is in constant velocity. So if the charge is moving in constant velocity, so then if the charge is moving in constant velocity, if the charge is in motion with a constant velocity, so then there at everywhere in its surroundings, so there is a electric field is there. So addition of the electric field, so the magnetic field is generated by the charge particle. So electric field is already there. If the charge particle is there, if anywhere a charge particle is there, so definitely, so at everywhere in its surroundings the electric field is there. So addition of the electric field, if the charge particle is in constant velocity, so there is a magnetic field is also generated. Magnetic field is also generated by the charge particle. So here E and B, so both are generated. E and B both are generated. E means electric field, B means B denoted the magnetic field here. So if the charge particle is in acceleration, means it doesn't have the constant velocity, it will be moves in the variable velocity. The velocity of the charge particle is varies time to time, that means it is in acceleration, then electromagnetic waves are generated. So then what happened? EM waves, electromagnetic waves are generated. So these 3 points you must and should remember. So the first point is, if the charge particle is at rest position, so only electric field is generated at everywhere in its surroundings. If the charge particle is moving with constant velocity, then electric field, addition of electric field, there is a magnetic field also generated. So but if the charge particle is in acceleration, that means the velocity changes with respect to time, so then electromagnetic waves are generated by the charge particles. So the example of electromagnetic waves are the light wave. Light wave is a electromagnetic wave. Okay, so the X-rays, so gamma rays, so alpha rays, all these are electromagnetic waves. Now we have to go to the Oersted experiment. Okay, so in 1820 year, Oersted discovered that there is a relation between E and B, electric field and magnetic field, accidentally. So before discovered this relation, so everybody thought like that the electric field and magnetic field both are different. So but the Oersted proves that there is a relation between the electric field and magnetic field. So what is the Oersted statement? So first of all we see what is the Oersted statement. So moving charges or currents produce magnetic field in its surrounding space. So moving charges are also called as moving charges. So moving charges means the electrons are flowing from one place to another place. So that motion of the electrons are also called as, we called as currents. So that's why the moving charges or currents produces produced magnetic field so at everywhere in its surroundings. So that statement is stated by the Oersted. So this is the first evidence. So this is the first evidence. First evidence to a relation between the electric field and magnetic field. So this is the first evidence, a relation between the electric field and magnetic field. So this is the Oersted experiment. So we know that the compass needle. So we know that a compass needle. So here this is the compass and so for example this is a compass needle. So everybody we have to know about the compass needle. So the compass shows always north direction. The compass shows from south to north direction of the earth. So why? Because earth has the magnetic field from the south to north. So that's why the compass needle shows always north direction. So the colored pointer is always shows towards the north direction. So this compass needle accidentally, so the Oersted placed it nearer to the current carrying conductor. So then what happens? So he observed that the compass needle get deflected. The compass needle get deflected. So actually the compass needle, so at anywhere we can place on the earth, the compass needle always shows north direction of the earth direction. So why? Because the earth has the magnetic field from the south to north direction. So but accidentally the Oersted placed the compass needle is nearer to the current carrying conductor. Then he observed that the compass needle get deflected. Here if we can take a current carrying conducting wire and the current I is passing through this wire, the current I is passing through this wire, so then the magnetic field is generated at everywhere in its surroundings of that wire. So like this. So the magnetic field is generated at everywhere on that wire, around that wire. So like this. So this is called as the magnetic field B and I. So magnetic field is denoted by the letter B. So for example if we can take a battery and we connect a current carrying wire, a conducting wire, so from positive terminal to negative terminal, so then the current is flowing from positive terminal to negative terminal here. Then if we can place a compass needle very nearer to this current carrying conducting wire, then the compass needle get deflected. So if we remove the wire from the circuit, if we remove the wire from the circuit, then the compass needle goes to its previous position, that is the north position, north direction of the earth. So here if you reverse the current direction, so that means the positive negative terminals of the battery will be so reversed. So then what happened? The compass needle is deflected in opposite direction. So the compass needle get deflected in the opposite direction of the previous direction. So that's why if the current direction is reversed, then the magnetic field direction is also reversed. So we can knew about this experiment. That experiment is practically, so we can do in this class also. So you can observe that experiment so carefully.
సో ఇప్పుడు ఇక్కడ మనకు కంపాస్ నీడిల్ అవపడుతుంది. సో దీంతో ఆయిస్టెడ్ ఎక్స్పెరిమెంట్ని మనం చేద్దాం. కంపాస్ నీడిల్ ఎప్పుడు ఎర్త్ యొక్క సౌత్ టు నార్త్ డైరెక్షన్ని చూపెడుతుంది. దానికి దగ్గరగా వేరే మ్యాగ్నెట్ని తీసుకొచ్చినప్పుడు అది డిఫ్లెక్ట్ అవుతుంది. ఓకేనా? సో ఇప్పుడు మనము ఆయిస్టెడ్ ఎక్స్పెరిమెంట్ని చూద్దాం, ప్రాక్టికల్గా చేసి చూద్దాం. సో ఒక సెల్ని తీసుకొని సో దానికి ఒక వైర్ని పాజిటివ్ టు నెగిటివ్ టెర్మినల్కి కనెక్ట్ చేసాం. సో దానికి దగ్గరగా కంపాస్ నీడిల్ని ప్లేస్ చేసాం. సో ఇప్పుడు వైర్ చుట్టూ మ్యాగ్నెటిక్ ఫీల్డ్ జనరేట్ అవుతుంది. పాజిటివ్ టు నెగిటివ్ టర్మినల్కి కరెంట్ ఫ్లో అవుతుంది. సో మ్యాగ్నెటిక్ ఫీల్డ్ జనరేట్ అవుతుంది కాబట్టి కంపాస్ నీడిల్ లెఫ్ట్ సైడ్ డిఫ్లెక్ట్ అయింది, మీరు ఫిగర్లో చూడొచ్చు. సో నౌ ఇప్పుడు ఆ వైర్ని రిమూవ్ చేస్తే కంపాస్ నీడిల్ యాజ్ ఇట్ ఈజ్ సేమ్ నార్త్ డైరెక్షన్ చూపెడుతుంది, ఎర్త్ యొక్క నార్త్ డైరెక్షన్. ఇప్పుడు సెల్ని మనం రివర్స్ చేసాం, అంటే కరెంట్ డైరెక్షన్ని రివర్స్లో మనం ఫ్లో చేస్తే సో కంపాస్ నీడిల్ ఆపోజిట్ రైట్ సైడ్ డైరెక్షన్ మనకు డిఫ్లెక్ట్ అయింది. సో దీన్ని బట్టి మనము ఏమర్థం చేసుకోవచ్చు అంటే, సో హన్స్ క్రిస్టియన్ ఆయిస్టెడ్ ఒక డచ్ సైంటిస్ట్, అతను ఏమని చెప్పాడంటే, సో ఏ మ్యాగ్నెటిక్ ఫీల్డ్ ఈజ్ ప్రొడ్యూస్డ్ అరౌండ్ ఏ కరెంట్ క్యారింగ్ కండక్టర్ అని మనము కంక్లూడ్ చేయొచ్చు ఈ ఎక్స్పెరిమెంట్ ద్వారా. సో చూశారు కదా ఆయిస్టర్ ఎక్స్పెరిమెంట్ ఎలా చేసామో. సో దిస్ ఈజ్ అబౌట్ ఆయిస్టర్డ్ ఎక్స్పెరిమెంట్. ఓకే, థ్యాంక్ యూ.
So in this Oersted experiment, so the Oersted stated that so there is a relation between the electric field and magnetic field, and the moving charges or currents produces magnetic field at everywhere in its surroundings. So the current direction and the magnetic field direction so will be shown by the right hand thumb rule. Okay, so here for example, here for example, so this is a current carrying conducting wire, and the current will be flowing in this direction. So we can place our thumb in the current direction. Then so whatever the curl of the fingers, so for example this is a current carrying conducting wire, and the current is flows in this direction, in upward direction. So we can place our thumb so in the direction of the current, and so the fingers, so the curl of fingers is like this. So thumb is in the current direction, we can place it, the thumb is in the current direction, and the curl of the fingers so like this. So here the thumb represents the current direction, so then so the curl of the fingers around this wire so represents the magnetic field direction. We can place our finger in the current direction, then the curl direction, the curl of the finger direction shows the magnetic field direction. So magnetic field is denoted by the letter B. Already we knew that. So now if we reverse the current direction, then what happened? So if we reverse the current direction, then I can place my right hand thumb in the current direction, and so I can put the wire like this, and I can curl the fingers like this. So now the thumb represents the current direction, and so the curl of the fingers represents the magnetic field direction around the current carrying conductor. So here the magnetic field direction, so here the magnetic field direction is like this. The magnetic field direction is like this. So here this is the current direction, then the magnetic field direction is like this. If this is the current direction, then the magnetic field direction is like this. So that means if the current is in this direction, the magnetic field is in anti-clockwise. If the current is in this direction, the magnetic field is in clockwise. So here we can observe, if the current direction is reversed, then the magnetic field also reverse. The magnetic field direction is also reverse. So this current and magnetic field direction, so the current and magnetic field directions can be represented by can be shown by the right hand thumb rule. Okay, so and so how the right hand thumb rule, so how we can place the thumb, and how we can place the fingers, how we can identify the directions. So I can also, that video also can be attached to this one. So you can observe that video so carefully. So this is about Oersted experiment and the right hand thumb rule to represent the directions of the current and magnetic field.
సో ఈ వీడియోలో మనం ఇప్పుడు మ్యాగ్నెటిక్ ఫీల్డ్ డైరెక్షన్ చూద్దాం. సో ఇక్కడ యారో సింబల్ అప్వర్డ్ డైరెక్షన్లో ఉంది, అంటే కరెంట్ అప్వర్డ్ డైరెక్షన్లో ఉంది. సో మ్యాగ్నెటిక్ ఫీల్డ్ అనేది ఆ కరెంట్ క్యారింగ్ కండక్టర్కి యాంటీ క్లాక్ వైజ్ డైరెక్షన్లో రివాల్వ్ అవుతూ ఉంది. సో అంటే మ్యాగ్నెటిక్ ఫీల్డ్ యాంటీ క్లాక్ వైజ్లో ఉంది కరెంట్ అప్వర్డ్ డైరెక్షన్ ఉన్నప్పుడు. సో బట్ ఇప్పుడు మనము కరెంట్ డైరెక్షన్ని రివర్స్ చేద్దాం. సో కరెంట్ డైరెక్షన్ని ఇప్పుడు మనము డౌన్వర్డ్ డైరెక్షన్లో చేస్తే ఇప్పుడు మనకు మ్యాగ్నెటిక్ ఫీల్డ్ అనేది సో క్లాక్ వైజ్ డైరెక్షన్లో మనకు ఏర్పడుతుంది. సో ఈ వీడియోలో మీరు చూడొచ్చు క్లాక్ వైజ్ డైరెక్షన్లో సర్కిల్స్ అనేవి మ్యాగ్నెటిక్ ఫీల్డ్ అనేది తిరుగుతూ ఉంది. I think everybody is clear from this video. So this is Kranthi signing off. Thank you.